Titrations and buffers. Book problems, exercise 59. A 25 milliliter sample of 0.1 molar ammonia Kb of 1.8 times 10 to the negative fifth is titrated with 0.1 molar of HCl solution. Calculate the pH after the addition of 0 milliliters, 8 milliliters, 12.5 milliliters, 25 milliliters, and 30 milliliters.
What you already know is that pH equals the negative log of the concentration of H plus ions. POH equals the negative log of the concentration of OH minus ions. The POH equals 14 minus the pH. The pH equals 14 minus the POH. pH equals pKa plus the log of the concentration of base over the concentration of the acid, which is also Henderson-Hasselbalch's equation. And Ka equals 10 to the negative 14 over Kb.
For part A, we are not adding any HCl, so we are calculating the initial pH. We are going to do ice for this equation, and we are going to use the initial molarity given to us, and for the product side we don't have any yet. Then we subtract X from the reactant side and we add X to the product side, and in the equivalence we're going to have 0.1 minus X, and in the product side we're going to have X and X. So now we write down our Kb expression, which is 1.8 times 10 to the negative 5 equals X squared over 0.1. So when we solve for X, we are going to have 0.0013 molar, which is the concentration of the OH. We plug this into our POH equation. So POH equals negative log of the OH concentration, which is 0.0013. So our POH is going to be 2.87. And then we subtract 14 minus 2.87 equals 11.13, which is our pH.
So for part B, we're adding 8 milliliters of HCl, which is also 0.008 liters of HCl. And for this one, our equation is ammonia plus H plus yields ammonium plus H2O. And for this, we're going to use Becca to find the amount of moles that we have left of acids and base. So before, we have 0.0025 moles of NH3, and we get that by multiplying the volume times the molarity. And for the H plus, we have 8 times 10 to the negative 4 moles, and we get that by multiplying 0.008 liters times the molarity. And our change is subtracting the least amount of moles, which is 8 times 10 to the negative 4 by the reactants, and we add the, 8 times 10 to the negative 4 to the products. And so we are left with 0.0017 moles of ammonia and 8 times 10 to the negative 4 moles of ammonium. And we convert those to molarity, so 0.0017 divided by 0.025 plus 0.008 liters, which is 0.033 liters, equals 0.052 molarity, and 8 times 10 to the negative 4 divided by 0.033 liters equals 0.024 molarity. And we are going to plug in those concentrations into the Henderson-Hasselbalch equation later, but for now we have to find the Ka still. So we take the Kb and plug it in, and we get 10 to the negative 14 over 1.8 times 10 to the negative 5 equals 5.6 times 10 to the negative 10. And then we plug it into the Henderson-Hasselbalch equation. So pH equals negative log of 5.6 times 10 to the negative 10 plus log of 0.024 divided by 0.052. And you get your pH of 9.59.
For part C, we're going to add 12.5 milliliters of HCl, which is the same as 0.0125 liters of HCl. So we are going to do Becca with these values. After we subtract the minimum amount of moles, we obtain that the concentration of ammonia and ammonium is going to be the same, and it's going to be 0.033 molar. So we are going to plug this into our Henderson-Hasselbalch equation. So it's going to be negative log of the Ka, which is 5.6 times 10 to the negative 10, plus the log of the base over the acid. But in this case, the concentration of the base and the acid is going to be the same, so it's going to be the log of 1. And when we take the log of 1, this is 0, so it's the same as not plugging in that part of the equation. The pH for this part is going to be 9.59, 25, and this is the halfway equivalence point. And we know this because the concentration of the acid equals the concentration of the base.
For part D, we're adding 25 milliliters of HCl, or 0.025 liters. So our equation is ammonia plus H plus yields ammonium plus H2O. And again, we're going to do Becca. And this time, you'll notice that the least amount of moles is actually the same for both reactants. So we're left with no reactants after the reaction occurs, but we are left with 0.0025 moles of ammonium. And when we convert that to molarity, we get 0.05 molar of ammonium. And then do an ice equation to find out the H plus that we have left. And this will give us our pH. So 0.05 molar of ammonium, and initially we have 0 molar of ammonia and the H plus. So after we do the ice table, we set up our Ka expression, and this equals 5.6 times 10 to the negative 10 equals x squared over 0.05. And then when we solve for x, we get 5.3 times 10 to the negative 6 molar, which is our concentration of the H plus. And the pH equals negative log of the concentration of H plus. So pH equals negative log of 5.3 times 10 to the negative 6, and that equals 5.28.
For part E, we're going to add 30 milliliters of HCl, which is the same thing as 0.03 liters of HCl. So we are going to do Becca for this part, and once we subtract again the least amount of moles of the reactants, we are going to be left with 0.009 molar of H plus and 0.045 molar of ammonium. So in here we already have our concentration of the H plus, so we just plug that into our pH equation, negative log of H concentration. So the pH equals to negative log of 0.009, and our pH is going to be 2.04. Thank you.
Thanks.